Uh,
Yes, sir.
can we start now? So the session.
I'll give you your brief introduction, then we'll start.
Yeah, thank you, ma'am. Thanks for that.
Welcome. A very good afternoon to one and all. On behalf of Electrical Engineering Department SCET and our entire team of FDP, I warmly welcome our eminent speaker, Chandrasekhar Ravindar Reddy, sir. Sir is an application engineer with DesignTech System Private Limited, specializing in the areas of modeling, simulation, control, and real-time simulations. He holds a bachelor degree in electrical engineering from JNTU Hyderabad and master degree in power electronics from JNTU Hyderabad. He closely works with consumers from defense labs and other education institutes in helping them adopt model-based design approach using Method products. He has over 10 years of experience working in controls of automotive, aero, and renewable energy domain. Today, sir will share his experience on modeling of microgrid and role of renewable source. Thank you, sir. We are delighted to have you. Over to you, sir.
Thank you, ma'am. Thanks for introducing to me. Quickly, I'll go to the sharing my screen. I hope is my screen is visible to everyone.
Yes, sir, it is visible.
Yeah, thank you, ma'am. Good afternoon, everyone. Myself, Ravindar Reddy. I'm working in the DesignTech Systems as application engineer. Here is my contact details are here, email ID and contact number. Today's our topic is modeling of microgrid and role of renewable energy source with using MATLAB and simulating software. So this presentation is next 1 hour. I'm going to talk about the microgrid as well as renewable energy, how we can use the renewable energy to modeling and simulation using the MATLAB and simulating software. In this presentation, if you have any doubt or maybe you have any question or any specific related like a query, you can reach out to me, stop over there, and you can unmute yourself and you can ask me the question over there. And later you need any support or maybe you need any clarification, reach out over this email ID and contact number. I hope my voice also is audible to everyone. Thanks for giving this opportunity. Yeah, I'm going to enter into the presentation. So as we discussed today, we are talking about the microgrid and renewable energy. Before that, I'm asking the question to everyone, like, can you respond in the Dropbox? How many people have idea about the MATLAB and simulating software? Can you quickly update in the like chat box, like how many people are using currently MATLAB software? How many people are aware using the MATLAB and simulating software? So that depends on that. I can update one by one.
Dear participant, please write your answer in chat box. Whether you are aware about this MATLAB or not, or are you using it, please give your response.
I'm requested the participant, please update so that based on that your maybe knowledge, then I can talk like more about that in terms of MATLAB and simulating software, like what are the features are available, and at presently the latest version is there, and what is the like more in the updated in the latest version, so that I can talk more about in terms of like updations. Yeah, thank you. Thanks for few people are updated, aware with MATLAB and simulating. Yes, sir. Yes. Yeah. Like good. Thanks for updating here. I think
Ravindar, I guess almost more than 70% participants would be aware, more or less aware would be with the MATLAB. So
yeah.
Hardly 20-25% may not be well aware. Then they must be aware, but they may not be well aware, or they might not have worked with the MATLAB. So that could be possible.
Yeah. Like my overall like aim is like if the people are aware, like I'll concentration more on more like latest updation, what is there and what are the futures are available in terms of smart grid.
Yeah, sure.
That is the reason I was asking. Thanks, sir. Thanks for updating here. Yeah, thanks for participation, like everyone, updated here. Yeah. Like you're able to see in my slide, there is a like a similar word, some of the like pictures are here is maybe like is the sources or maybe conversion or maybe AC, like there's a G, like some of the similar words is there. So when we are talking about the like microgrid, like before like modeling of the microgrid, before that we are talking about the renewable energy. So maybe in terms of renewable energy or non-renewable energy, definitely the power has to we have to stabilize using the like grid or maybe smart grid or any time from the grid. So grid is a main aim to control the stabilize the power. So, but the futures are is available in the MATLAB, and what are the tools we can use to control the and we can stabilize the power, and maybe we can conversion. For example, we require the DC power. Maybe in the renewable energy source, we are getting the DC power. How we can do the conversion or inversion? And what are the like prototype real time where we can use a real time application. For example, I have the MATLAB code or maybe I have the Simulink model. Then how I am taking to the in real time applications, and maybe similar kind of the grid how I can use in the real time application, whether I can convert to the code that feasibility or is available or not. So maybe like not only MATLAB, many other software systems, but how MATLAB will help you to design this kind of the microgrids and renewable energy. Then how we can do it in the real time application. This is the like agenda I'm going to talk another 1 hour. Yeah, this is a like slide. I can talk about the like focuses of the area, grid model, modernization of and maybe digitalization. So here you're able to see like some of the transmission systems is it, that is nothing is the flexible AC transmission system. Some of the like renewable energy, as I said, there is a wind power applications is there. These are the maybe wind turbines is there, and as well as the solar panels, or maybe like I can use like thermal applications. So different like a power generation sources are available here, and immediately I can take into the power. Maybe I can connect with the grid, through the grid I can able to send it to some of the consumers here. Maybe that I'm using the like vehicle applications, as well as I can use like home power applications. I can use like industry application. So this is the overall concept. So the grid monetization. So here is a, like I can talk is grid integrations. So how grid will help you, and there are some analytics is the grid analytics, and we have to the monitoring and control. So why I'm talking this is three things. So whenever we get the power, we have to stabilization the power, and we have to conversion whether we require AC power or DC power. So that is we can do it in the grid integration level, and after that we have to analytics that maybe how much power I'm getting. So that power and monitoring and controls. So how much power I have to distribute to like as a home power applications, as well as like commercial applications, or maybe like a vehicle applications like automotive. So this is a monitoring and controllers also it is available. So this is a, like engine is used to map those tools across the utility of the industry value. So here you're able to see there is a wind turbines or maybe generators from the power generation. I have to do touch the transmission from this place to this is a substation. From the substation, we can send it to the factories, as well as this is we can call it as a distribution. From a transmission up to the power generation plant to the substation, we can do the transmission. After that substation, we have to distribute to the factories, offices, or maybe home power applications or electrical vehicle. These are the things that it is available here. So this is a like how to distribution transmission. These are the tools will help you that methods across the utility of the industry value. So first, when we talk about the grid, then ultimately there is a power generation sources is there. That is a wind turbines as well as the generators. So this is a wind turbine is completely it is a renewable energy that is comes from the nature is continuously it is there is a no pollution like the wind turbines. How the wind turbines we can do it in the MATLAB. How the power plant we can design in using the MATLAB and Simulink, as well as the generators. And after the transmission, in the transmission
મોમાં
also,
મૂક્યો હોય ટીના લાવજે બીજું લઈ લે કરવાનું એક કાર્ડ ને બે શું લઈને જવું ગાડી લઈ જવું
yeah, I'm request to the participant, please mute yourself. If you have any question, please stop me over there and you can ask me the question
મૂકી દે
over the place. Thank you.
તો હંમેશા કોઈ આવી વસ્તુ લઈને જાઓ ને કોઈ બેગ એને ફોલ્ડર ની અંદર મૂકીને જવું, એમને હાથમાં પકડીને નહીં.
Please mute yourself. Mr. Rakesh, please mute yourself. Host.
Yes, sir.
Please mute.
પેલા એક ડોક્યુમેન્ટ આપેલો હોય, ખાસ કરીને ઓરિજિનલ ડોક્યુમેન્ટ આપે. આપણું મગજ બેગ લેવામાં હોય ને પેલો પાસપોર્ટ લેવાનું ભૂલી જાય એટલે ફેરવવાનું.
Yeah, I think it's not in the seat, I think.
Yes, sir, I have removed.
Yeah, thank
You
you.
can continue.
Yeah, thank you. So after that is a phasor measurement unit. These are the like tools where it is available, and that as well as in substation, that is the smart switches, we can use it here, and after that the distribution systems. So these are the like smart meters. Then we can use like a vehicle applications. These are the like many places where we can use but the tools is available in terms of like a MathWorks, that is a MATLAB and similar software. So these are some of the case studies is there where they can use like a solar panel that is nothing but renewable energy. Then after that they want to connect the grid, and how they're converting. Why? Because when we talk about the solar panel, ultimately we get it in the DC power. How the DC power is generating from the solar panel, then how the power to convert, and we can send it to the grid. After the grid, how we can distribute. This is a concept. This is one of the case study is there. This is a solution they use Simlink as well as Simscape Electrical to model and simulate the microgrid distribution system, which is photovoltaic sources. In these results, there is like a model development time is cut off by 80%, and cost reduced through the battery right sizing and simulation accuracy is verified the real-time kind of the data. This is one of the case studies published public. Then later on this session I can share this link to everyone, like you can go through this link and maybe you can find out. And here is some of the power system design analytics solutions is there, where is a grid integrations and grid analytics and monitoring and control. This is a like I have divided as a 3 subsystems. So here is a grid integration. We have to the grid integration, we get the power on how to we can perform the power quality and harmonic studies and techno-economic analytics we can did it. And complaints, we have the perform the complaint studies, that is an ERS, MOD, IEEE 1547. These are some standards we can do it in the perform complaint studies. And after that we can develop the microgrid there where we can use in real kind of the things or power plant. So we can develop the microgrids and develop the control statistics here. So this is a part of the grid integration. So once it is done, then we can go for as analytics. From here we can do it in the like how to the power we can give it to like one place to another, transmission and distribution, and how to boost up time performance update, reduce the risk factor. Then we can do it here. And after that, energy and price forecasting we can do it here. And we have to the variation risk management, outage of the reductions is there. And after that is a monitoring is there. That is a cloud deployment tool. It is we can host it in the forecast and deploy to the solution in the cloud. And real-time simulation, that is actually we are into here hardware in the loop simulation. And after that we can use like parallel computing to perform the large number of analytics and using the we can faster in the simulation quickly. So these are some solutions. And where we can talk about the grid integration studies, like renewable energy and DER, like design and simulate electrical machines and control system, perform the power quality and harmonics. And if you want to develop any kind of the controller optimization algorithms, and if you want to integrate such kind of the like a PSSE and a PSCADA to large system level simulation, so we can integrate that things. So here is a power plant model validation and parameter calibrations using the PMUs and digital twins. These are the things we can use it in the active power, reactive power values we can measure, and we can pull up the data from the grid itself. This, as I said, there is a like IEEE 154 complaints we checked here. These are some case studies here. So So grid analytics and visualization also we can use the signal processing tools and AI techniques from here, and we can develop the predictive maintenance as per that expectation algorithms. And analyzing the grid stability with soft like PI MATLAB using here, and energy pricing and forecasting also we can do it here. So monitoring and controlling digitalization using the cloud, we can using GPUs and IoT devices from the grid and real-time kind of the things. As I said, once you're happy with this assembling model, we can deploy to go for this hardware in the loop simulation. So in terms of we are using, these are the tools we can use developing the grid, that is using the Simscape electrical in terms of smart grid technologies. So as you're aware, this is a MATLAB software, and the MATLAB software, I hope it is everywhere aware about the Simlink library browser. Quickly, I can launch the Simlink library browser. So what are the tools are available from the MATLAB and Simlink side? At present, I'm using the MATLAB R2021B. This is the latest version. Sorry. Yeah, it is opening. Just by the time I can go to back. So in that my next the aim is I am going to design any kind of the same grid and renewable energy. For that I'm using that Simlink. So this is a Simlink. We can do it a simulation and model based designing. So we can maybe we can if we want to see code and C plus register code, we can generate out of our Simlink models also. So, but what is using the Simlink? So here we have to do it model and simulate your systems, and you can test it is oftenly, and you can generate the code automatically from that your model. And these are some of the applications where we can use in Simlink. I can talk about the wireless communication, motor controller, control system, signal processing and robotics, and advanced driver assistance, or image processing and computer vision, Internet of the Things. These are the few applications I was mentioned here, so I can use it here. These are the Mathos product family where we can use MATLAB in terms of MPhil coding, how to solve some kind of the mathematical equation, statistics and machine learning and optimization. If I want to deploy into some kind of the application deployment, if I want to access some kind of the report, I can use it in MATLAB. But when I'm talking about the grid and maybe renewable energy, power plant designings, or maybe FACTS, or maybe HVDC or HVAC, certain kind of the things I want to do it in MATLAB, I can use a Simlink. This is a simulation and model based designing here. So here we have to the real kind of the simulation testings is available, and we can do it in the verification and validation test also. We can do it here, and we can do it we can generate the report, simulation graphics, and reporting option also is there. This way can do it in the event based modeling and physical modeling. These are the application I can use control system, SPC signal processing and communication, and image processing and computer vision or computational finance. So these are the places I can able to use it in thing here. Somebody's raised hand. Please, can you unmute yourself and you can ask me any question?
Hello, sir. Hello.
Yeah.
Sir, I have one question.
Yeah.
On the screen, there is a two dialog box I've seen, and there is an option that the code generation. So if
Correct.
I can prepare a simulation or kind of model of any kind of system, and if I can I generate the code for the same using a software?
Thing is, for example, sorry, echo is coming. Yeah. For example, how the simulink to model. Out of the model, if you want to see code, it's HDL code or maybe VHL code, you can able to generate the code. And the code you can use it in, for example, if you are generating the C code, definitely then you are using the C code, maybe in any ARM processor or microcontroller, correct? No, like if you're generating the VHL code, the VHL code you can deploy into maybe Xilinx or Zinc boards, or maybe Z boards, or maybe if you're using any kind of the real-time application. In the software level, you can able to see the simulation in the MATLAB. But if you want to, in terms of the hardware, definitely you require the code. For example, I'm an expert in the MATLAB, but I don't have much idea about the C language, or maybe C place, or maybe VHDL. But still, I can generate my MATLAB to C code, or maybe my Simulink to C code. The C code I can directly deploy into the hardware. That the hardware, it will act in the real-time application. Is it clear? Any doubts?
Yes, sir. Thank you so much, sir.
Hello?
Yes, sir. Thank you so much.
Ma'am, your voice is not clear.
Hello, sir. Thank you so much. Hello.
Yeah, hello?
Yes, sir. I get the point. Thank you so much.
Yeah, I hope it is clear. Otherwise, just your voice is not clear. You can update in the chat box, madam. Later, maybe I can clearly explain you. I can take one of the model. I can generate the C code and as well as HDL code. I'll show you what are the hardwares are supported to code generation, and what are the modules are supported. Thank you, ma'am. Thank you. Yeah, if you have any doubt, please unmute yourself and you can ask me the question or the place. This is a code generation. This code generation, it will support to either your MATLAB or Simulink model. We can able to generate the code. These are the features are available in the latest version, and previous version also is there. But year on year, depends on the customer requirement, or education, defense, or commercial. That depends on the requirement. We are updating year on year. So these are some of the application in terms of the smart grid. They have to improve the adaptiveness of the transmission lines, quick recovery after any sudden breakage, or maybe disturbances in the lines, or maybe feeders. Cost reduction also is there, and reduction of the peak demand. And they have the process of ability integrated with these renewable energy sources on large level of the, which is leads to sharing the load reduction and load large scale. So here, if you clearly observe, this is my grid, but here is the arrow mark is there. So in the thermal power plant, I can generate the power, industrial plant, solar plant, wind power plant. These are the power generation units, and these are the consumers, electrical vehicle, smart houses, cities, offices, or hospitals. So these are the consumers, these are the power generation units. But if you observe, like Ravindar, why I use grid? What is the point of the grid? Like starting inwards, I'm talking about the grid and renewable energy. So I hope everybody aware renewable energy is nothing but it comes to nature, that is a free of cost, like solar energy, wind power, we can say this is we can say is a renewable energy. This is a non-renewable energy. This is comes as a nuclear power plant, thermal power plant, industrial plant. We can generate the physically we can generate the power from the AC. But here solar we can comes to DC, and wind it comes to AC. But whether here AC or DC, what are the power it will comes, but as a consumer we require AC only. Apart from the electrical vehicle and smart houses, cities and offices, hospitals, we require the AC power. But our input is not constant. Solar always is not constant, depends on the sunlight. Sometimes is going to increase and decreasing. Ultimately, the power generation plant is maybe sometimes I'm getting the high power, sometimes I'm getting the low power. Here is not constant. But when I'm talking about the wind also, wind also always is wind is not constant. Sometimes is going to increase, sometimes is going to decrease. But industrial plant, thermal plant, nuclear plant, maybe I can control, but still that variable AC is there. But here variable AC, variable DC, and high power, low power, powers is comes to every time. But if I same for example, this is my cities and offices, I'm using the power. If I connect directly the solar power or wind power, so ultimately my system it will damage. Like because this is a power is not constant, it is always is going to increase and decreasing. So first we have to stabilize the power, and we want to eliminate the unwanted harmonics, and after that I want to distribute the power to consumers. That is a repair power. So first I want to stabilize and how to control the power in that I can use in only for grid. In grid level, I can control, I can distribute the equal power to that all consumers. So maybe either AC or DC, I have to convert to variable AC to constant AC. If I got the DC, variable DC to constant DC. So in the power electron terms, I can use the converters, inverters, choppers, rectifier circuits, and everything we can do it in the grid level. So after the grid, the power has to like stability, then of the stable power, I can send it to the consumer. That's the reason we can use the grid technology. In the grid, like a lot of the smart gates, like larger gates, I can use a different kind of, so the grids I can use it here. So if it is a renewable energy, my grid is completely depends on the renewable energy. Then again, renewable energy, whether I connect with the solar power or wind power. Why? Because solar is getting the DC and wind is comes to the AC, asynchronous. But this both are again is not concerned how to stabilize the power. That is do it in the smart grid. So this is a purpose we can use like grid. Basically, what does a smart grid? So again, the same answer it will affect. So here is a there is a like wind energy, solar energy, nuclear power plant, thermal plants. So all the like power I'm getting to here, the grid has to control. After the grid, I want to distribute to the consumers. So here, smart gates perform smart jobs. That is the advantage of the smart gates. Stated flow, like efficient transmission and distribution electrical power. Quickly, we can restore the electrical power after failure of due to faults. Low cost for operation and maintenance for a management and electrical electricity, both of the utility consumers. Low electrical power traffic is there, and provide the better option to integration with the renewable energy for self power generation system, improve the security and protections. So these are the things we can do it in the smart grid. Yes, Ravinder, as you said, like in grid, we can stabilize the power, maybe a variable to constant, or maybe a variable DC to constant DC, variable AC to constant. But how I'll do it, how I'll develop the grid in using the MATLAB and Simulink. But when we talk about the MATLAB and Simulink, then we have the dedicated tool is the SimScape. Previously, we can call to the SimPower system. Now we have the SimScape tools is there. When you go to the MATLAB command window, you can type the SL library browser. Otherwise, you can type the first two similar words, SL, and you can use a tab. It will show, it will come up here. This is a like tools, it will come up. So here I want to the Simlink library browser. You can select the Simlink library browser and you can launch the Simlink library browser here. This is the one way. Otherwise, you can click on the Simlink block itself. I hope it is clear. If you have any question or any query, please unmute yourself and you can ask me over here. Yeah. So now I'm in the Simlink library browser. This is a Simlink. I think everybody aware about the Simlink. So there is a common user blocks is there, whether you're working in the like power electronics or electrical or maybe electronics or computers or mechanical or any other division. So definitely the basic tools, it will help you to design your model. That is nothing but basic Simlink. So if you're able to observe, there is a wireless, there is a discrete, discontinuous, lookup tables, math operations, matrix operations, and some of the things, source, all those things it is available here. After that, if you want to like work on the especially electrical side, if you want to design any kind of the like a grid, or maybe you want to design any kind of the renewable energy power plant, or maybe if you want to develop the distribution transmission system, or maybe flexible AC transmission system, then you can use the SimScape. So here is a SimScape is there. Once you click on the SimScape, this is a block sets are available here. So first one is a foundation library. In that foundation library, you're able to see the electrical. So this is a we can call to previously the SimScape electrical. Under the electrical, there is a electrical elements is available. So these are the like same as you are in that like textbook academic, like same capacitor, diodes, all the elements are available. So when you click on the electrical sources, current sources, voltage sensors is there, and sorry, electrical sources, AC, DC, and everything it is there. And similar way, there's a downside. One more electrical is there. Once you click on the electrical, when I'm going to the click on the specialized power system, here is the power electronics is there. When you click on the power electronics, so power electronics controls is there. So this is a pulse generators, pulse with modulation, space vector pulse generator, space vector pulse generator, pulse generating unit is there. And click on the power grid elements. So there is a directly block sets are available in the latest version. So you did not to develop this kind of the models. Why? Because it is already pre-developed is there. So here is the like as a, some of the power grid elements is available here. Is it clear up to this step? If you have any question or query, please unmute yourself and you can ask me the question.
No, it is clear. You can go ahead.
Thank you, sir. Thanks for the update here. So this is the power grid elements is available when you click on the sources. Why? Because most of the people are looking where are the sources is available and utilities is there, and you're getting that one more doubt whether what are the sources. For example, if I want to generate the if I want to build the wind power plant, or maybe if I want to build the like a solar power plant, Ravindar, whether the models are available or not. So those kind of the models is directly is available in the here in the latest version. Quickly, just I'll show you. This kind of the motors, general machines is available here. Elements is there, sensor sources is there. When you type on that synchronous brushless DC motors, mechanical things is available here. In the power electrons, you are able to see on the thyristor switches, IGBT plus diodes. The switches are available to help you the design the like a circuits to conversion of the power electronics related. Power electronics controllers also is available. Power electronics grid elements also is available. Yeah, sorry, here it is not there. Integrated circuit logic also is available. Passive elements, RLC thermal transforms, different kind of the transform. You did not to build any kind of the transforms. By default, Zig Delta, Wi-Fi, transforms, earthing transform, multi-inductors. These are the all of the transforms are available here. When you click on the cell, fuel cell is available. Quickly, just a bit about the solar and wind power plants also is available. Quickly, I will show you. Multi-body sources, power electronics, specialized power systems, controllers, electrical foundation library, Simscape. Yeah, no issue. So you can come to here. One way you can able to search in the simulation library. That is a one way. Go to click on the library browser. You can sorry. You can type the solar, maybe solar panel directly it is available. Sorry, just a minute. I'll show you. This is a one way you can able to directly search on the library browser. Otherwise, latest maybe many people are aware. I think you can type to here also. It will act as a like for example, if I want to the solar panel, just you can type the here. Solar cell, if you want to like if you maybe if I want to create any kind of the solar cell, or maybe if I want to create a wind power plant. Just you can type the similar words in the window itself. Otherwise, you can type onto here in the search button also. For example, if I want to design any kind of the plant, maybe solar. Previously, what happened? PV cell you have to design, but now by default the panel, the cell it is available. The cell, how many cells you want, you can click on the particular toolboxes and you can increase the parameters. So this is a place like in the Simscape, under Simscape electrical it is there. So here we have the some semiconductor circuits and IEEE low voltage feedback. Some of the circuits are here. Through the toolboxes we can able to design. So with the Simscape electrical you can evaluate the analyze circuits and develop the mechatronic systems with electrical drives, and we can analyze the generation, conversion, transmission, and this is a power grid level we can able to design. That is okay, Ravinder. If I want to like make it my own block, for example, like there is a custom capacitor I want to design. So for that, you have to write the equation in the MATLAB code, and you can create your own like Simulink model. That Simulink model you can import to in the simulation library, and you can able to use it. This is also is possible. That's why in the Simulink video help you to design. There is a custom models also. So here are the some semiconductors in the is there. If you want to design any kind of the semiconductors, or maybe power losses, or maybe if you want to subset of the libraries, you're able to design here. So in the electrical system, so there is a systems is there like how to the power, motor, and pump we can able to design. That maybe we can able to see the analyze report in the scope, and after that we want to do any kind of the conversion. We can switching dynamics, switch on off condition. If I want to AC power, that I want to variable AC to constant DC, I can do the converter that converts. I convert the DC link is get it here. From the DC, if I want again AC, then constant DC to constant DC conversion I can do. That AC I can use it in the power application. So that's the result. Like we have to the conversion and inversion option also it is there. That kind of the circuits are available in the like MATLAB. So later is a smart grid. Smart grid electrical networks is a combination of the electrical network, that is digital communication technologies. So this is capable of the providing the electrical power from the multiple widely distribution sources, from the like wind turbine, solar power systems, and prefers even plug-in hybrid electrical vehicles. So this is a basic operation and principle of the smart grid. So we have the like multiple plants, coal plant or industry power plant or medium power plant, hydroelectrical power plants. So these are the power plants we use to get the power. That power has to customize, and we can say we can deliver to the like home power application, that is a consumer. And this is a two-bus system. Quickly, I can go to this example. I'll show you. And before that, just I can go to the simulation library browser. These are the things is there. This is available in the library of the source, and solar cell is there. So if you want to design any kind of the solar panel, so here also this is a like a solar panel. If you want to more know about the solar panel, click on the particular model and go to the help. When you click on the help, so it will show you the library place and what is the principle of the particular block. So this is a solar panel, is nothing but we can consider as a photovoltaic solar cell. This is a library is available under Simscape electrical sources is there. So if I go to the Simscape under the electrical, under the sources. So here is the sources. If you want to design any kind of the PV kind of the things, photovoltaic cells and fuel cells. So these are the cells is available here. And the next one is if I want to design any kind of the wind power plant. So thingy just click on to wind power plant. Wind turbine or wind function. So if I want to design any kind of the wind power plant, I can use the wind turbine induction generator also is there. So here I want to see the generator speed. If I give the some apply to some generator speed and that angle I have to apply to here, I want to apply the wind speed so that I can get it the time per unit I can generate the wind turbine. So once I double click on this particular block, then I can get it like what are the nominal mechanical output voltage, what is the base power of the electrical generators I have to apply to here, and after that I want to display the turbine power characteristics here. Any doubt from this slide? If you have any doubt, please unmute yourself and you can ask me the question here. Yeah, these are the characteristics of the particular wind turbines it will show you. So here is like max power at basic wind speed 12 meter per second. There is a bit 0 degrees. So these are the like turbine versus is a turbine power nominal mechanical powers it will show here. So this is the like one of the example, and quickly just back to here. So these are the places we can use. These are the like first principle up to modeling and data driven. So we have to use like MATLAB and Simulink. After that, we have to depend on the Simscape, and after that, we can mathematical calculation. We can use the system identification toolbox and the machine learning toolbox. So this is the first principle. We can use it in the Simulink also, but for advanced, we can use the Simulink components because these are the photo type of the photovoltaic cells is available directly in the physical component that is in Simscape, and advanced library we have the directly the blocks which is available. Same block I can use it in 3 stages: Simlink, Simscape, and Simscape electronics also. Why? Because as you are everybody aware, previously we can call to the SimPower system. What are the SimPower system? We can do it in the Simlink also, it is possible. But here we have to spend more time extra, and we can have to do like more components. But when we are coming to the Simscape, there is a using of the models are very less, and we can be when we can enter into the Simscape, there is a very less libraries are is there. Why? Because solar cell is freely available, and quickly we can take it here and we can apply our values and we can get it the output. So this is a where like MATLAB we can use quickly, and we can save some time for development. And how does PV cell it will work? There is a like a PN junction, it is there. We have the anti-reflector layers is there, backplane is there. So whenever that some kind of the solar like maybe sunlight will across on the PN junction, so it will eliminate the protons and electrons it will come. That is a photo generation short circuit current, the propagation of the number of photons are across PN junction when photon energy HN E gap. So electron starts come, that is maybe depends on the like parameters 0.6 to 0.7 volts has to reduce. So this is a PV cell equation, equivalent circuit model is there. So here I'm using the solar in inducent current. Like here I am using the diode saturation current. These are the where I have to mention using my equations. So these are the outputs has to come. That is a diode forward voltage and diode reverse voltage. So this is the same thing. If I go to the real time, then I have to import the test data to my Eligen boards. So here is a programmable solar simulator is there. So what are the models have? I can generate the C code. I can deploy to the hardware that PV plant under tested here. So this is a generator of the surface of the fit for experimental VI curves here. And after that, we can use lookup tables. This here I'm using the 2D lookup tables here to model in the simulation. So like a modeling of the power turns, we have the like, for example, as I said in the starting, when we are getting the solar panel DC power, maybe the DC is not constant. So again, I have to do the variable DC to constant DC. For that, I'm using the Simscape electronics nonlinear simulation equations I'm using here. So here, similar way, there is a Simscape power system. We have the variable DC to constant DC. I can use it the same kind of the simulation here. So here, when using the solar panel, we can use the like MPPT algorithm, that is a maximum power pan tracking system. So when the PV arrays needs to operate at the near maximum power point MPP to extract the maximum possible power from the model and maybe increasing the overall efficiency. So photovoltaic curve and cells is there. Incremental inductance algorithms also I can use it here. That is MPPT. This is a maximum power point leveraging of the power electronics. I can affect the temperatures of the performance of the photovoltaic arrays. So when increasing and irradiance and increasing the temperature, increases in the temperature. So this is a PV load and this is a load. In general, when we can talk about the model directly from the connected the load and operating point send them the MPP. So here is a power converter I'm using here. From this place, I can convert the voltage and current that I'm using the PWM technique, pulse width modulation, using the MPPT algorithm plus duty cycle adjustment. For this, build up the like multiple phases, multiple level inverter circuits using the universal bridge from the Simpower system library. So this is a modeling PV cell series strings is there. So we have to connect over this. And here is a like a PV operating PV curve it has to come. This is a configuration of the PV model in the configuration, how we are connecting the centralization strings, multi-strings models. So this is a, like a, one of the grid integrated how we are connecting the packs, flexible AC transfer system devices. So how we are getting the power and how do we can do the customization here. This is a solar PV system grid integrations is there. Just quickly, I can back to the my presentation here. I can click on the Simscape electrical. Otherwise, just back to here. So here, if everybody interested, I'll show some reference paper also, where the actively general paper, how we can implement it in using the MATLAB and Simulink. This is one of the IEEE transaction paper. It is there. This is a grid interconnection of the renewable energy source with the distribution level, wind power quality, improvement features. So this is the one IEEE paper is there. This is a block diagram where they're implemented in the real-time applications. So here is a grid is there, but here is a renewable energy source that is maybe solar as well as wind. The picture you will indicate. After that power, they want to using the DC that they connect to the DSP controller, digital signal processing controller. After that, they are send it to they send it to the switches. So here is they're using the 4-leg converter. 4-leg converter means like a one switches, two switches, both combination is nothing but 1-leg converter. This is the 4-leg converter they used here. After that, they're using the like L inductance. They want to eliminate the unwanted harmonics. After that, they connected with the distribution system. The distribution system is sent to the grid. In the grid, they control the power quality, and after that, they send to transformer as well as into the loads. So this is a like one of the reference paper IEEE transaction. According to that, we are designing using the MATLAB and Simulink tools. So here they see the like voltage and current and different level. So similar way, quickly just I opened this kind of the example to here. This is my overall simulation circuit here. So here, as I mentioned, renewable energy, that is RES, renewable energy. When I click open this link, this is a like solar panels I'm designing here. I want to like A and B. There is a solar panels is there. So under the solar panel, if you want to see the inside, this is a like PV model. This I'm using the MPPT algorithm, maximum power point tracking system. So in the PV model, then I'm using the solar panel configuration. So here I want to give certain like temperature or maybe that area I have to calculate, and after that I want to track the maximum voltage and current from this model that I am using the MPPT. After that, any unwanted harmonics I'm using the RLC circuit. So resistance, inductance, and capacitance. If I remove unwanted harmonics, after that pure power I can send it to the consumer. So this is the way here. So this is my controller techniques I'm using. That is like a pulse width modulation, PI, PID control I'm using here. So here I'm using the PI control technique. So this is a PI control technique. And initially, someone was asking the query about the Ravindar, how I can able to convert the code conversion. So from this place, you can click on the apps. When you click on the apps, recently we entered in the Simlink apps also. When you click on the apps, so you're coming to downside, there is a code generation area is there. So if I want to like a C code target to the any kind of the hardware, there's an embedded code is there. Or maybe some people want to like Simlink to C code, there's a Simlink code is there. Or AutoStar complaints, DDDS or HDL coder I want. Otherwise, some people want to work on the PLC coder, or some people want to work on the fixed point. These are the like DO qualification kit, IES certification kit. These are the things is available. No, Ravinder, I'm working on the real-time Simlink, real-time desktop, real-time. I can use like Simlink desktop real-time testing also. I want to work in the Simlink in the loop, maybe processor in the loop. I want to do is a code verifier, or maybe a processor in the loop. I can maybe if I want to work on any kind of the hardware, get the hardware support package also is available. I want to generate the report. Maybe I want to see the Simlink 3D animation that is possible is there. How my grid is behaving, what is my grid parameters, that you can able to do it here. For that, you can click on the modeling. Once you click on the modeling, there is a model settings is there. Once you click on the model settings, go to the model settings here. So once you click on the like model setting, there is a configuration parameters. It will show here. This is like a configuration and parameters is there. So here, if you want to know the like starting time, stopping time, you can able to control. And if you want to the solver configuration, you can select the solver configuration. And if you want to import any kind of the data, for example, maybe I have the some plant data is there. I want to import the data into the MATLAB and Simulink. I can select the data here. I can import to my MATLAB environment. And when we talk about the hardware, what are the hardware you want? For example, these are the all the hardwares are supported already tied with MATLAB, AMD, ARM compatible, Altera, analog devices, microchip. These are the hardwares is there. So if you want to generate the code, which code you want, VHDL or Verilog, you can see. Maybe some people want to work on the like what we can say like C or maybe C, C+. You can able to generate here. Any doubt till this stage? Shabir sir, any doubt?
No. Please, you can continue, Ravinder.
Thank you, sir. Thank you. So this is the like configuration, and you can set the server configuration. If you want to referencing any simulation target code generation, you can able to select here. This is like a SimScape multi-board. These are the some of the setups is there. Maybe who are using the MATLAB and Simulink latest version, you can able to see that this many options are available. If you want to create the subsystem, automatic subsystem, these are the things is available here. At simulation time, ultimately you can able to control as per your parameters. You can able to control the starting time and stopping time. And the measurement, you're able to see the values of the, maybe if I want to see the grid level voltage, maybe if I want to see the like a consumer level voltage, how much voltage is the grid load side, or maybe like starting and ending time. So these are all those parameters you're able to see from this place. So this is a place I can take the renewable energy. After that, grid interfaces inverters. When I open the grid interfaces inverter, these are the switch configuration is there. So these are the switches I'm designing here. So here in the each and every two switches, both combination is nothing but I can call to one leg converter. This is a 4-leg converter, 3 phases, 1 neutral, right? Totally 4 phases is there. So over excess voltage, I can store it here. This is a capacitance. This is a capacitance 3000 into minus 6. I'm using here Henry's. So after that, I'm using the some kind of the filter. I want to eliminate the unwanted harmonics. After that, I want to use the circuit breakers. Then after that, I want to send you to the distribution system. In the distribution system, maybe you can step up or step down as per your convenience. You can able to do that. So this is all things are editable. Maybe it depends on your requirement. You can able to edit the parameters to here. And after that, you can send to the sources. In the sources, we can able to control the power quality, and after that, we can send to the consumer, that is the loads. So this is a where we can able to design this such kind of the like a power grid and renewable energy source power plant. So quickly, just I want to take one of the example. Already it is there in the MATLAB. Same example I want to show you. Just I want to close down here. I want to clear my command window, clear all. Close all, so we'll see. Yeah. So here is one more reference paper. It is there. Maybe these are the one of the IEEE reference paper. It is there. This is a StartCom control scheme from the grid connected wind energy. When I show in the last time, that is a solar. This is a wind. So here also like how they are designing the wind power plant, how their batteries StartCom, how they are using, and after that how they send it to the load application. These are the one of the IEEE paper reference paper is there, and after that there is a results here that are copied here in the transaction paper. This is a reference paper. We can able to design the like Simlink circuits to using the MATLAB and Simlink. Yeah, I think yeah my solar grid panel is open. So here you are able to see here. This is like a power grid. So power grid, they're simply saying that as a like a step down transform, step up transform they're using here. This is like as per the basic parameters here. Later on, if you want to edit the parameters, you can able to do it parameters here. So this is a solar panel. When I open the solar panel, this is the solar internal solar cell. It is there. When the battery, I can say as the battery measurements is the internal snubber. After that, they have the like consumer side is there here. So quickly, just I want to run this model. Here I'm using the 24 into 60 into 60 totally complete day. I want to run this simulation. So whenever I have the solar panel, I can use a solar panel, and rest of the times I can use the like battery. And continuously 24 hours I send it to the like power to the consumers. This is a completely simulation circuit using the MATLAB and Simlink. So these are the transformers, polo mounted transformers, like filters, power grid, solar, battery, everything using like MATLAB Simlink libraries only. So how solar panel is going to starting from zero slowly, how they're increasing, and what is the secondary power, what is the load power, what is the battery power, what is the SOC like hours. So this is a charts are indicating to the power charging, discharging, load side. This is already PQ power quality. So this is like voltage and current. And this is a battery charging and discharging mode. How starting from zero slowly is going to charging. So whenever we get the solar power, it's going to charge, and whenever solar panel is not there, is going to discharge. So this all of the operations are it is done in the grid only. After the grid, they can send it to the consumer. So grid itself we can balancing the like a power, maybe if any unwanted harmonics is there we can eliminate, and we can customize the power, stable the power, and stable power we can send it to the consumers. For this, these are the components using simulation library here itself. Maybe if you want to see the simulation manager, like here data inspector logic, like these are the things is available here. So this is the place how we are converting the solar panel variable DC to constant DC. After that, we can send to the buck converter. After that, we have to do use a DC to AC inverter. That AC we can use in the utility grid, and we can use it in the load application. So these are the one more of the case study where Alastom Grid develops is a high voltage direct current transmission control system using the model based design. I think everybody knows ABB accelerator application control software development for power electronic controllers. And what microgrids? So utility grids is a microgrids. We can able to renewable energy. So from that we can send to the these are the some of the commercial industries, residential industry. We can able to distribute the power. And we have the supervised controls also is there. These are the layers of the control talks, microgrids. These are the uninterrupted power supplies is there, seconds. And we have the designs and implemented in the real time, and we can test in the prototype actual power plant system. So what are the like desktop simulation we can able to generate the C code generation and implement it in the real time. After that, we can do it in the test in the hardware. So these are the like demand response and optimization servers and comfort. The time, energy, also prices also is important. Weather also is there, and how billing save 20% heating and coding the codes. And this is a degree Celsius is there. 25% of the code reductions also it is there. Energy management system EMSR is a must. That why we have to use the static policies is there. Offline data, manual operations also it is there. And this is a like model-based designing optimization where require the MATLAB. So the, some of the challenges is the designing algorithm optimally control equipments and deploy into the system embedded enterprises. So for this, we have these other tools is required: MATLAB, Simulink, libraries, and Simscape and optimization. These are the workflow optimization and integrated with the deployment tool MATLAB as well as a Simlink, Simscape, Stateflow. And this is the integration with this enterprises IT. There is a databases is there, analytics and business systems. These are the load management systems is there. Tenco is like there is a one of the case study. Additional development if you want to build any kind of the wind power plant. This has a blades, hub, uh, generators, like tower height, the width of the grid, everything it is there. So this is a deployment process. Once you got the requirement, we can control the software, embedded software is different, mechanical software, electrical is separate. For this, we have the integration test and we can able to do it here. So these are all those things that we can able to do it here. And this is the acceleration innovation utilities of the energy industries. These are the things is there. And again, if you are new to MATLAB or maybe Simulink, or otherwise if you are expert in the MATLAB Simulink, if you need like more about the like power grid related or maybe tax or maybe renewable energy, if you want to design your own, we recommended go to the documentation. Under the documentation, we have the Simscape electricals is there. Under the Simscape electrical, there is a specialized power systems is there. Under the specialized power system, there is a renewable energy systems. So here these are the some of the case studies is available, examples are available. Later on you can go to there is a different values is there. Partial standing PV models, 400 kilowatts grid connected PV farm is there. These are the some multiple examples is there. So you can go through this example. This is a freely available. uh, I'm sharing this link to everyone in the chat box. Whenever you have free time, you can go through this link. You can get it the examples from over here. Maybe if you want to work on the wind or solar, these are the renewable energy source related blocks are available. And this is when you click on the functions, what are the functions are available in the MATLAB Simlink, it will show here. And there's a blocks and any other apps it is there, it will show here. And when you click on the example, it will come up here. Yeah, this is from my end side. Like last one, there is a like some of the like a self-based online courses is available. This is a like freely available for everyone who are having the campus for license. They can able to access from their college official email ID. If the college doesn't have the CW license, like you can able to create your own Mathos account. You can get it the like these are the courses is available. MATLAB, deep learning, Simlink, state flow, machine learning, control system, and some other 6 courses also it is there.
So Ravindar, for that, the institute must have the license for the MATLAB, no?
Yeah, if they have
It
the
is,
license,
it is for those who are having the license version.
yeah, that is a license version. Okay, if the people doesn't have the license, still they can able to access from their own account. So, for example, if you go to this MathWorks account page, click on the Mathos account and go to the sign in the particular page. If you have the campus file license is okay. If it doesn't have the campus file license, you can create your own personal email ID and you
Yes.
can get the some of the courses is there. So, for example, quickly just I want to show you. To show you what are the things are available freely. Yeah, when once you open this account, maybe you doesn't have the license, but you can able to access the some of the courses.
Okay.
Once you click on the my courses, so it shows like there's a my courses is there. These are the free courses, sir. Like see when you click on the homes, totally 12 courses are free, sir, for everyone who doesn't have the like license. Also, they can access the MATLAB, Simlink, circuit simulation, and RAM. Recently, we are introduced here. This is a more related to the Simscape, sir. So
Okay.
there is a one more Simscape and ramp also we are introducing here, sir. So maybe it is around 2 hours course is there. So here you're able to, this is an agenda course overview, building the Simscape models and understanding the physical signals. These are the agenda is there.
Okay.
So after this thing, you can get the certificate from the OEM itself, sir. Click on the certificate. You can get it the certificate. Once you complete the 100%, you can get it the certificate also from directly OEM MathWorks.
Okay. Okay.
So,
And
sorry, sir. Just quickly, I'll share this link to everyone. Who are interested, please go through this link and create the account and finish the course. So once you finish, then you'll get the certificate. This is a like certificate it is there. And yeah, this is from my end side. If you have any question, I'm ready to happy to tell the answers. If you have any question, please ask me here.
yes, participants, do you have any question? Meanwhile, they collect some question. I mean, whatever you have shown, that's the power_microgrid model in that some of the last slides.
Yes,
So,
sir.
are they available in the MATLAB, or that is made by customized model, or
No,
that
no,
is readily available?
no. It is available, sir. It is available, sir.
And from which version you have made it available? You're talking about 2021B version. So from
Correct,
which
sir.
version that model has been available?
All in the previous version, maybe you can talk about like a 20. Maybe I can say the 2020 onwards, but 2021B is the latest blocks are available.
Okay, okay. And in that whatever the sources are available, that sources can even be customized, or that few more sources can also be included if somebody wants to
Yes, sir. Yes, sir. Yes, sir. Yes, correct, sir. You can able to like import, and you can able to create, and you can able to design. So from that, if you need any help, please reach me over this email ID and contact number I shared in the chat box. Maybe you can we can discuss on the specific on the topic.
Yeah, sure, sure.
And one more request, I shared the like one of the feedback link to you here, sir. Just I'm requested to everyone, please fill this link details to here so that I can get the your response. According to that, I'll share the like slides and what are the content today. Then I'll share over this email.
Sure. All participants, please, you are requested to fill the feedback form that is shared by the Ravindar. And in future also, it may be useful. He may be in touch with you.
Yes, sir. Yes, correct, sir. And here I shared my details also. Or do you have any doubts specific? Please reach me over this email ID and contact number here. And Shabir sir, like one request to you, sir, if you are everybody interested, quickly I can show you the code generation products to here, sir, with your permission.
Yes, yes, please.
If you have the time, no issue.
No, you can, if it takes 5 to 10 minutes, then that would be fine. Even
Yes.
15 minutes, that would be fine.
Sure, sir. Sure, sir. Thank you, sir. Thank you. Thank you. Yeah, like as the ma'am requesting, maybe how we can able to generate the code. So quickly, just I want to take one model. SFIR fix. Yeah, I want to take a simple one model how to generate the C code or maybe HDL code. For example, this is my model. Maybe in this symmetric filter, if I want to generate the code particular model. So quickly, I can generate this code. Click on the right click on the particular model and click the, if you want to see code, you can click on the C place and go for the code generation advisor. Otherwise, if I want the HDL code, click on the HDL for workflow advisor. Once you click on the HDL workflow advisor, it will take into the what are the blocks are supported code generation or not. It will show you, and after that, it is asking the few steps how to generate the HDL code or maybe C code. This is a step, it will help you. And one more thing I'll tell you, sir, maybe if you people want to work on the in future, if they want to generate the code, there is a like library HDL. Oh, sorry. Yeah, otherwise, I can type the DOC documentation here. Go to the documentation page. Yeah, this is a documentation page. Like when you want to work on the code generation, click on the code generation. This is the Mathos side, MATLAB family side. There is a code generations are supported. This is the Simulink side. So when I want to work on the especially HDL code or maybe Simulink code, a C code, go to the Simulink coder and it will show you like what are the hardwares also. So here is a Simulink coder support for hardware. So ARM and Beagle boards, NXP, ST microcontroller things, it will show up to here. So if you want to get this hardware support packages, you can get the hardware support packages to here. Otherwise, you can come to here, click on the add-on here. Sir, you're able to see my screen? Yeah, I hope. Yeah, clear.
Yes, yes.
Yes, it's visible, sir.
Yeah, click on the add-on, go to the get the hardware support packages here. Maybe if your people want to work on the Arduino board or maybe Beagle board or maybe any kind of the like microcontroller, microprocessor, anything. So click on the add-on explore. So it is asking to these are the boards it will show here. For example, in future, if you want to work on the Simulink support packages for Arduino boards, so click on the Simulink support and go and click the install. So it is asking the Mathos account, that is a free of cost, and you can enter your Mathos ID and password. So this for this you don't want to pay anything, is a free of cost. Sorry, this is a taking time. This is a depends on your internet speed as well as your hardware. Yeah, manually just I will show you. Yeah, this is asking the Arduino boards and the licenses. So click on the next. It will go into download. I hope it is clear. For this code generation, so when you're asking the set the target, is asking the target devices. You have any hardware, you can select the hardware here. You can select the target frequency. And the check the model compatibility is there. Here is asking whether the particular blocks are supported to code generation or not. So he's checking the block settings, standard checks, configuration checks, everything that will check everything, and is going to generate the code. So quickly just I'm running this all those things. And here is asking the HDL or maybe VHDL. So if you want to select the HDL code and VHDL code, you can select over here over there, and you can generate. Same similarly C, C++ or maybe PLC code. And if you want to test bench and validation mode also, you can able to generate here. So this is a way like you did not do expert in the HL side and VHL and C code side. Once you're happy with your code, immediately you can able to generate the code, and you can deploy to certain kind of the hardware and other third-party softwares you can able to integrate.
Ravindar, you just mentioned a few minutes back that there are certain courses that can also be accessed with a normal account even without having the license.
Correct, sir. Correct, sir.
So where that could be found, can you just show once again?
Okay. Once you have the math,
because I have already my account, so I've just logged into my account.
Yeah, go to the in the left side. There is a My Courses. Is there, no sir? Once you click on the My Courses, sir.
No, I cannot find the My Courses on the page once I log in.
You're not able to you're not able to find out this My Courses.
No.
You're in the same page, sir. In this page, Mathos account.
Yes, I am on the MathWorks account. It's there. Product solutions, academic.
There is a
support, community events are there. Then on the left side, there is a documentation tab, and in that contains the documentation, home function, SimScape, electrical, specialized power system, then categories, electrical sources, motors, generators, but I couldn't find.
Can you open this link, sir? Just now I posted in the chat box. Can you open this link?
Just a minute. Yes, yes, I have opened that link, and in that. Yes, in that it is My Courses are there.
Yeah, click on the My Courses, sir.
Okay, browse self-paced online courses.
Correct, sir. There is a like self-based online courses, 18 courses is there. In the out of 18, I think who are is eligible the free courses, I will tell you quickly. When you click on the click on the home, there is a getting started is a 12 courses. These 12 courses are freely for everyone, sir.
Okay, home, and then okay. So in that one is that MATLAB on-ramp, then MATLAB fundamentals and data processing, visualization, programming techniques like.
Yeah.
Okay, and there are number of courses also. I think they are mentioned in the bracket that MATLAB 4, Simulink 5, and something like that.
Right, sir. You have the, I think, MathPass like a CW license. For that, you're maybe getting the more courses. But who doesn't have the like CW license, official license? If still they want to work on their own personal email ID, they can get these 12 courses. First, getting started. These are the 12 courses are freely for everyone.
Okay.
So here MATLAB installation also is not required, sir. Again, I'm telling to everyone. So this is the whenever you have the free time, you can finish this course and complete is working on the MATLAB cloud or MATLAB online.
Yes. So that's why it can even be conveyed to the students, those who are interested in working in that things.
Right, sir. I hope it is clear. Still, if anybody having any doubt, please unmute yourself and you can ask me over here. So here, here VHL code is generated from this model, And this VHL code I can run into the Xilinx or Zinc software, or maybe I can deploy into any kind of the hardware also.
Yes, participants, if you have any query, please.
Yeah, please unmute yourself and you can ask me the question.
Yes, nobody is having.
Yeah, this is a code generating. Maybe this is a code you can able to deploy into the hardware. I'm requesting to everyone, please let me know if you have any question. I'm ready to help you. Otherwise, later on, if you have any question, please drop it my email ID so that I can able to get it that in the. So in the response side, around 13 people only fill the feedback form. I'm requesting to everyone, please fill the feedback form and submit over your side.
Yes, please. All are requested to fill up the form.
And sir, after this session, can you send me the from your side the participation list to my email ID, sir?
Sure. If nobody is having any question, I have also filled the form, Ravindar.
Yeah, sir. Thank you, sir.
So, shall we wind up this session, participants, if you do not have any query? Okay, so I guess Ravinder, they might have their questions raised later, so that will be diverted to you. And you, as you have already shared your contact and mail ID, so probably some of you might be in touch with you regarding the MATLAB, the features available or whatever they want. Anyway, it was a very interesting session, and though most of us are familiar with the some functionality of the MATLAB, though it may be that depends upon how depth one has gone into,
Yes, sir.
but
Yes, sir.
everybody is a little bit familiar with the MATLAB and some of the features of the MATLAB. So anyway, you have tried to explore some of the features which may not be aware of by all of us. So that would be a great. That was the great session,
Thank
and
you, sir.
I'm very much thankful for your presentation and your DesignTech, and we would be grateful if you share your presentation if possible,
Sure,
so
sir.
that
Sure.
can be shared with the participants.
Sure, sir. Sure, sure.
Okay, thank you very much, Ravinder.
Thank you, sir.
Participants, Ravinder, you may leave the meeting, no problem.
Okay, sir. Okay, sir. Thank you, sir.
Thank you very much.
Thank you, sir.
Participants, just wait a while.